So students, the next chapter that we are going to do is lines and angles. This is a very important chapter of mathematics. Why? Let's say take an example. If we want to construct a plan or we want to construct a design of a building, right? We need to draw some parallel lines and then we need to draw some intersecting lines. So we need to know the property of parallel lines as well as intersecting lines both, right? In physics, we deal with reflection as well as refraction of light, right? So to prove some properties of reflection as well as refraction, we need to know the know-abouts of angles and lines both, right? If we are given a building and we want to find the height of the building, right, without even using a scale, because that would be practically impossible, we can do it with the help of angles, right? So angles and lines, it is very important in mathematics, right? So let's start with the chapter. Let's take a look at what we are going to do in this chapter. We'll deal with some basic terms and definition first, then we'll talk about what are parallel lines and what are transversals, right? Then we'll talk about a property of lines which are parallel to the same line. Then at the end we'll talk about angles and property of a triangle, right? So let's start with the chapter. Now we'll talk about some basic terms which we already know, but I'll brush it up for you quickly, right? So first of all, what is a line? What is a line? Line is anything or any one-dimensional figure which extends in both directions till infinity. Here we can see that this is going in this direction as well and this is going in this direction as well, right? So here this is extending indefinitely in both the direction, so that is called line. This is a one-dimensional figure, right? Now what is a ray? What if I try to fix one endpoint of this line? If I try to fix one endpoint, let's say I fix a point here, then this is a ray. It has one fixed point. This is our fixed point, and the other point, it goes up to infinity. So this is indefinite, but it has one fixed point, right? Or it can be shown as this form, where this is the fixed point and the ray is extended in this right direction. The ray can extend in either left or the right direction. That won't make any difference, right? Now what if we try to fix both the endpoints of a line? If we try to fix both the endpoints, right? Let's say I take a point here and I take a point here. Let me call this point as C and let me call this point as D. What am I going to get is nothing but CD. So here CD, there would be a defined length of CD, right? This is the first endpoint and this is the second endpoint. So it has two fixed endpoints. Two fixed endpoints, right? And because the endpoints are fixed, so its length would be fixed. In Euclid's geometry, this line segment was called as terminated line, right? It was called terminated line. Terminated line, right? So now we know what is a line. When we try to fix one point on a line, we get a ray, right? When we try to fix both the endpoints on a line, we get a line segment. The length of a line segment is defined, right? Now let's talk about collinear points and non-collinear points. You must be knowing that if there are more than 2 points, let's say 3 or 4 points, and if all the points they lie on the same line, if all the points lie on the same line, then they are called as collinear points, right? If I have here I have 3 points, and if I can draw a straight line that passes through all the 3 points, then these points are called as collinear points. So I can say A, B and C are collinear, right? So what would be non-collinear? By logic it says if I have some points A, B and C, and if I am unable to draw a single line that passes through all the points, like for example if I try to draw a line here AB, this line AB won't pass through C, so C would be left out, right? So these are called A, B and C are non-collinear points because they don't lie on the same line, and these points A, B and C here, they lie on the same line. That's why they are called collinear points, right? Now let's talk about angle. Now what is an angle? Angle is nothing but, if we take two rays, here I have taken one ray and I have taken another ray, and both the rays are intersecting at a point, this point, right? I have two rays, both the rays are intersecting at this point, then this is called the angle between the two rays, right? So angle, it is subtended between two rays that are emanating from a single same point, right? Now the single same point of the two rays is called the vertex. It is called the vertex of the angle, as you can see from the figure, right? And the two rays are called nothing but the arms of the angle. So we have, what is an angle? We have the arms of the angle, and then we have the vertex of the angle, right? Now an angle can be defined as an acute angle, a right angle, an obtuse angle, or a straight line, or a reflex angle, right? Now before going into details of these angles, let me draw some angles for you. Let's say, so what is the trick? If I want to draw, let's say 0 degree, or let's say I'll start with 90 degree. Now what is 90 degree? All this you already know, so I am going to take a brief look up on this. This is 90 degree. This is our first arm OA, and this is arm OB, and this is 90 degree. This is 90 degree. Now how do we represent 0 degree? Now what would be 0 degree? OA has not moved any angle. So OA lies here and OB also lies here only. So this is nothing but, this was right angle or 90 degree. This was 0 angle. This is 0 angle because the ray has not moved anywhere. It has not covered anything. Here the ray OA is moving from here to here. It has covered 90 degree. Now what would be 180 degree? 180 degree would be, we have the ray OA and OA starts from here and it takes half of the revolution, right? It takes half of the rotation. So this angle is nothing but 180 degree. So this is 180 degree angle. And what would be 360? 360 would be, we started with OA, we took half of the rotation, we got 180 degree, then we took another half because 180 plus 180 is 360 and we landed back on OA. Now this is 360 degree, but how I am going to show this? I am going to show this like this, because we traveled from here to the same point. In this case we didn't travel anything, so this is called 0 angle, but this is called 360 degree angle, and this is 180 degree angle, right? Here we started from OA, then we took one complete rotation and we then landed on OA only, right? So this is right 90 degree, 0 degree, 180 degree and 360 degree. Now let's talk about acute angle, right angle, obtuse angle, straight line and reflex angle.